The ACE plugin provides many ways to mix native UI into your Cordova app. I'm going to demonstrate this with the PhoneGap Day conference app, which was built with ACE. Here's the app running on iOS and Android, and it's an Ionic app, but the tabs here at the bottom on iOS are native, and they're switching the main view, which is still the Cordova web view. And here I am on Android doing the same thing. If we look at the code, we can see that in JavaScript, we're loading a markup file defining the native UI with tabs. Then we're going to replace the web view with new native UI, and then reparent the web view inside of that native UI. Looking at the markup file, we can see it's just a tab bar with those 4 buttons defining the icon, label, and what should happen when they're clicked. And when they're clicked, it updates the native page title and then opens the page that we expect. This is just one of many ways to mix and match HTML and native UI. ACE provides various cross-platform panels to make it easy for you to arrange the content in all sorts of different layouts. But next we're going to look at overlaying native UI on top of HTML. Although the last example used XAML markup to define the native UI, that's just one of many options. You could completely build your UI programmatically in JavaScript, or for Android you can still use Android XML, and iOS you can use Interface Builder, and you can easily integrate this UI into your Cordova app. However, if you use JavaScript or XAML markup, that gives you the extra option of using a cross-platform UI framework that enables you to just write your UI once and have it work on all the platforms. But if you want or need to write platform-specific UI, you can still do that in JavaScript or XAML. And that's actually what we're going to see next. On the session detail page in this app, I want to provide the user a way to rate the session. So I've got JavaScript that here on Android creates a rating bar control. There's no cross-platform abstraction for this, and I've got no wrapper class, but that's okay. ACE allows me to instantiate arbitrary native objects and then invoke instance members on it. Like here, I'm saying that the user's only allowed to do whole star ratings on this control. I'm persisting values in local storage, so I retrieve it here and set the rating if I get one. I listen for changes directly from this Java control in this case, and persist the new rating. And then, since I'm overlaying this, I use a pop-up to explicitly position this native Java control on top of the HTML in the case of Android. For iOS, there is no rating bar control, so instead, I'm directly instantiating a UI segmented control, and then I'm going to fill it with 5 segments, each one containing 1 through 5 star characters. I do the same thing with the local storage and initialize the rating, listen for changes to the segment selection and set the rating appropriately, and then explicitly position this inside a pop-up. So let's see what this looks like. I'll pick the Bluetooth Low Energy session on iOS, and here's the UI segmented control hovering on top of the HTML. Notice that translucency and transparency works as you'd hope it would. If I go to that same session on Android, there is the Android rating bar control allowing whole star ratings only, and I can rate that session. The next native UI integration we're going to look at is full screen. So here we're going to navigate to a new page, and that is a filter page. This enables the user to filter their sessions based on the tracks they want to see. Now this is an entirely native page, and if we look at the code, again I'm loading a XAML file and I'm navigating to it with a Navigate API. This doesn't have to be a XAML file, it could be Android or iOS specific markup, or I could programmatically create the whole page and then call navigate passing that root object instance. But here, with a XAML file, I'm going to grab a list box by name from it, grab its done button so I can attach a click event handler that processes the selections from the user and then passes it along to the rest of the app. And then I can populate the list box with all the controls, so a simple label at the top, a toggle switch for each track and setting its state appropriately, and then 2 buttons at the bottom, one that deselects all the toggle switches, one that selects all the toggle switches. So I've combined the productivity of still just defining my UI once with all the benefits that pure native UI gives you, and there are a lot of benefits. One is performance. The scrolling is as smooth as it can be because it's all native controls, no web view refreshing, no JavaScript user code needs to be invoked as you're scrolling. The back button works because it's true native navigation to new native pages. And because it's pure native UI, it integrates nicely with user settings or developer settings. So here I've turned on force right to left layout and draw layout rectangles, and the native UI respects that, whereas UI inside the web view would not respect that. On iOS, I can change the accessibility settings and change the way buttons and switches are rendered. When I do that, the native controls respect that because they are pure native controls. All the buttons throughout that are native, from the underlines at the bottom to the way they're rendered in the navigation bar on the top. Even the tab bar buttons are now rendered differently, respecting the user's accessibility settings, which is very important. Even though this example programmatically navigated to the new page, you don't have to do it that way. In fact, from your HTML, you can link directly to markup files, whether it's XAML, Android XML, or an Apple Interface Builder file. So here I have a link to a ratings page, in this case defined in XAML. I will click it on the iPhone, and actually I'll bring it up on Android as well. And this is just a native page that happens to show the stored user ratings. It's similar to the other one, but the navigation was done with a simple hyperlink. The last main scenario we'll look at is Android specific, and that's incorporating an app widget into your Cordova app. When you use the ACE plugin, your app can have a native folder that contains native code and resources per platform. The iOS folder can contain Objective-C, whether it's your own custom code or third-party code, and you can easily instantiate and use that from your JavaScript. The Android folder can contain Java and various Android resources, and in this case, I have resources that define some app widgets for my app. Now, ACE has some built-in widget APIs that make it easy for you to manage your widget from your JavaScript code. So when the app runs, I'm going to clear the data in my app widgets, and then I'm going to populate it with all the schedule information that the app shows in its main web view. But this time, it's going to do it via pure native UI in the Android app widget. And then when the user clicks on an item in the widget, it's going to detect that, and then it's going to navigate to the right HTML page that shows the details for that session. And then, just to demonstrate the invocation of arbitrary native code, in this case it's a platform API, this JavaScript is showing an Android toast at the bottom of the screen. So it uses these raw reflection-like APIs to get a string constant and then invoke toast.makeText, and on the returned instance, show a toast that says, here's the event. In fact, the About page that we already looked at also had some JavaScript to invoke some native platform APIs, in this case, different ones on iOS versus Android, and it did that to show the model and, in the case of iOS, the name of the phone. But let's finish this demo by showing an app widget on Android. I'll bring up the widget UI, scroll to the bottom, which has two widgets for this app. I'll add the one, and you can see all the same schedule data that's in the main app. So let me click on the Bluetooth session we looked at earlier, and there's the session, and there was the toast.